close your eyes for just a moment and imagine the sky above you not as something distant, but as something gently watching over you. Above the quiet rooftops of sleeping cities, above drifting clouds and silent mountain peaks, there stretches an ocean so vast that even light takes millions of years to cross it. Tonight, we begin a slow and gentle journey into that ocean, toward distant galaxies that shimmer softly in the dark like forgotten lanterns from another age of the universe. Long before humanity learned to build telescopes, before maps were drawn, before names were given to stars, those distant galaxies were already there. They were spinning quietly in the dark, unaware of the tiny blue planet that would one day look up and wonder about them. And what makes them so fascinating, so deeply calming, is not just their beauty, but their patience. A distant galaxy does not rush. It does not hurry. It turns slowly, gracefully, over billions of years, like a cosmic dancer performing a routine so slow that it feels almost still. When we look at a distant galaxy, we are not seeing it as it is now. We are seeing it as it was millions, sometimes billions, of years ago. The light reaching your eyes tonight may have begun its journey before Earth even had forests, before the first birds flew, before the first humans dreamed. That soft glow in the telescope lens is ancient history arriving gently at your doorstep. Imagine floating above the Earth and traveling outward. First, we pass the moon, silent and pale. Then we drift beyond Mars, beyond Jupiter, past the icy giants at the edge of our solar system. Soon, our sun becomes just another star among billions in the Milky Way. And then even our Milky Way, our home galaxy, begins to shrink into a glowing spiral in the distance. What once felt unimaginably large becomes just one among trillions. Scientists estimate that there may be hundreds of billions, perhaps even trillions, of galaxies in the observable universe. Each galaxy contains billions or trillions of stars. Around many of those stars, planets quietly orbit. And on some of those planets, perhaps oceans shimmer, winds blow. Maybe, just maybe, life exists, gazing back into the darkness as we do. Distant galaxies come in many shapes. Some are spirals, with elegant arms curling outward like cosmic seashells. Others are massive elliptical giants, glowing softly like golden clouds. Some are irregular, shaped by collisions and gravitational dances that stretch them into unusual forms. Each one tells a story, a slow-motion story written in gravity and time. What is most soothing about distant galaxies is their scale. They remind us that the worries of a single day are tiny ripples in a universe that moves at a much slower rhythm. While we hurry through hours, galaxies drift through eons. While we count seconds, they count billions of years. Light from distant galaxies travels through expanding space. The universe itself is stretching, gently pulling galaxies farther apart. This discovery, first observed by astronomers studying faint red shifts in galaxy light, revealed something extraordinary. The universe is not static. It is alive with motion, expanding like a breath slowly exhaled. And yet, despite this expansion, gravity still binds stars within each galaxy. Massive black holes sit quietly at the centers of most galaxies, including our own. They do not roar or consume everything around them as movies suggest. Instead, they sit calmly, anchoring their galaxies like deep roots beneath a tree. As you listen to this, imagine yourself drifting closer to one of these distant galaxies. Its stars shine like grains of silver sand scattered across velvet darkness. Nebulae glow softly in pinks and blues. Dust lanes weave delicate patterns through spiraling arms. Everything moves, but so slowly that it feels like stillness. Some galaxies are so far away that they appear as faint smudges even in powerful telescopes. Yet those tiny smudges hold more stars than we can imagine. The idea that something so immense can look so small from here is humbling and strangely comforting. In the early 20th century, astronomers once believed that our Milky Way was the entire universe. Then careful observations revealed that certain fuzzy patches of light were not clouds within our galaxy, but entirely separate galaxies of their own. The universe suddenly became far larger than anyone had dared to imagine. And with that realization came a sense of awe that still lingers today. Distant galaxies are time capsules. Some formed when the universe was young, only a few 100 million years after the Big Bang. Their light carries information about the early cosmos, about how the first stars ignited and how the first heavy elements were forged in stellar hearts. As night deepens outside your window, remember that the sky is not empty. It is layered with depth beyond comprehension. Behind every visible star lies a background of galaxies so distant that their light is barely whispering across space. You are not small in this universe. You are part of it. The atoms in your body were forged in ancient stars, perhaps in distant galaxies long gone. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all born in stellar furnaces. And somewhere, far beyond the Milky Way, a distant galaxy is quietly turning, unaware that on a small planet called Earth, someone is listening to a story about it, feeling calmer with every word. Long before stars glittered across the sky, before galaxies formed their graceful spirals, the universe was a very different place. It was younger, hotter, and filled not with light as we know it, but with a glowing mist of energy and possibility. If we gently drift backward through time, beyond the Milky Way, beyond the earliest stars, beyond even the first galaxies, we arrive at a quiet beginning. A moment when everything that would ever exist was compressed into a state so dense and bright that imagination struggles to hold it. In those first moments after the universe began expanding, there were no galaxies. There were no stars. There were no planets. There was only a sea of particles, tiny building blocks moving through a rapidly stretching space. The universe was like a warm fog, glowing faintly, filled with hydrogen and helium forming from the cooling aftermath of the cosmic beginning. It was silent in a way we cannot truly understand, because sound itself requires air, and space had none. Yet there was motion everywhere, gentle flows, ripples of density, slight variations in the smoothness of matter. Those tiny ripples would change everything. Over millions of years, gravity began its quiet work. It is the most patient force in the universe. It does not rush. It does not shout. It simply pulls, softly and steadily. In regions where matter was slightly denser than its surroundings, gravity gathered more and more material, drawing hydrogen and helium into invisible clouds that slowly thickened. These clouds were enormous beyond comprehension, stretching across distances far greater than entire modern galaxies. As they grew denser, something magical happened. Pressure and temperature at their centers increased. The first stars ignited. Imagine the darkness of the early universe suddenly pierced by points of brilliant light. These first stars were unlike most stars today. They were enormous, blazing hot, and short-lived. They burned fiercely, fusing simple hydrogen into heavier elements like carbon and oxygen, elements that would one day form planets, oceans, and living beings. In their final moments, many of these first stars exploded in titanic supernovae, scattering newly formed elements into space like cosmic seeds. These seeds enriched the surrounding gas, allowing new generations of stars to form with greater complexity. And slowly, as gravity continued weaving its invisible threads, stars began clustering together. Small star systems merged into larger ones. Clouds collided. Matter swirled. Structures began to emerge. This was the birth of galaxies. The earliest galaxies were smaller and more chaotic than the grand spirals we see today. They were irregular collections of young stars, glowing brightly in a universe still finding its shape. Over billions of years, these early galaxies collided and merged, growing larger through cosmic partnerships. Each merger reshaped them, stretching stars into long arcs, compressing gas into new bursts of star formation, creating luminous centers where supermassive black holes quietly formed. At the heart of nearly every large galaxy today lies one of these black holes, ancient and massive, formed in the earliest eras of galactic assembly. They are not destructive monsters as often imagined, but stabilizing anchors, influencing the motion of stars around them with deep gravitational presence. Even in the infancy of the cosmos, these central giants were already shaping their galaxies' destinies. As galaxies grew, they began to take on distinct forms. Some developed swirling arms, guided by the rotation of their mass. Others became elliptical, rounded, and smooth, formed from repeated mergers that scrambled orderly motion into more random stellar paths. Each galaxy carried within it the history of its formation, scars of past collisions, regions glowing with newborn stars, quiet outer halos filled with ancient ones. What makes this story so calming is its slowness. The formation of a galaxy is not a violent explosion that ends quickly. It is a gradual gathering, a slow choreography performed over billions of years. If you could watch it unfold in real time, it would appear almost motionless, like frost slowly spreading across glass. Even now, in the modern universe, galaxies continue to form and evolve. Far away, in regions where gas clouds remain abundant, new stars are igniting. Small galaxies are merging into larger ones. The cosmic story is still being written, though at a pace so gentle that human lifetimes are barely a blink within it. When we observe distant galaxies through powerful telescopes, we are looking back in time toward this early era. Some galaxies we see are so far away that their light began traveling toward us when the universe was only a fraction of its current age. In their faint glow, astronomers read clues about how the first galaxies assembled, how star formation rates changed, and how structure gradually emerged from primordial simplicity. It is astonishing to think that everything we know, every star in the night sky, every atom in our bodies, traces its origin to those early gatherings of gas and gravity. Without those first galaxies forming, there would be no chemical richness, no complex planets, no life pondering the cosmos. And yet, the birth of galaxies was not dramatic in the way we imagine fireworks or sudden bursts of action. It was more like the slow forming of clouds before dawn, a gradual shaping, a patient accumulation. If you imagine yourself drifting through that young universe, you would see darkness punctuated by growing islands of light. You would feel no wind, no sound, only the deep stillness of space. And within that stillness, gravity would be quietly at work, assembling the grand structures that would one day host countless stars and worlds. There is something profoundly soothing in knowing that the universe did not rush its creations. It allowed time to stretch and sculpt. It permitted galaxies to form layer by layer, star by star. It allowed complexity to bloom slowly from simplicity. Tonight, as you relax and let your thoughts soften, picture those first galaxies emerging from cosmic mist. See their newborn stars shining brightly in a young universe. Feel the immense patience woven into their formation. The galaxies we see today, majestic spirals and glowing ellipticals, are the result of billions of years of quiet evolution. They carry within them the memory of their birth, encoded in their stars and structures. And somewhere, in the unimaginable distance, ancient light from one of those first galaxies is still traveling toward us. It has been on its journey longer than Earth has existed. It crosses expanding space without hurry. It moves at the speed of light, yet even that speed feels gentle when measured against the scale of cosmic time. The story of distant galaxies is not just about vastness. It is about patience, transformation, and the quiet power of gravity shaping beauty out of simplicity. As we continue our journey, we will explore how these galaxies move, interact, and dance with one another across the expanding universe. For now, let the image of their birth settle softly in your mind, a universe awakening, slowly lighting its first stars, and beginning the timeless ballet of galaxies. If the birth of galaxies was a quiet awakening, then what follows is a dance, a slow and graceful movement guided by a force that never tires. That force is gravity. It does not sparkle like stars or glow like nebulae, yet it is the unseen choreographer behind every galaxy's motion. Tonight, as you settle deeper into calmness, imagine drifting between distant galaxies, watching them move not in haste, but in patient arcs across the vast dark ocean of space. Gravity is gentle, yet unstoppable. It is the reason stars gather instead of scatter. It is the reason galaxies hold their shapes instead of dissolving into dust. It is the reason the universe forms patterns rather than remaining a formless mist. Even across millions of light years, gravity reaches out with invisible threads, linking massive structures together in a cosmic web. Picture two distant galaxies suspended in the quiet darkness. At first, they appear separate, each spinning peacefully in its own rhythm. One may be a spiral, its arms curling like a luminous whirlpool. The other might be elliptical, glowing softly like a golden cloud. Between them lies a vast emptiness, yet gravity stretches silently across that emptiness, drawing them ever so slightly toward one another. This attraction is not sudden. It does not happen in days or centuries. It unfolds over hundreds of millions, even billions, of years. If you could observe their motion in real time, it would seem still. But if you could compress time, if you could watch millions of years pass in seconds, you would see them slowly approaching, their shapes beginning to distort as their gravitational fields interact. As galaxies draw closer, their outer stars feel the tug of the other's gravity. Long streams of stars begin to stretch outward like glowing ribbons. Gas clouds within each galaxy compress, triggering waves of new star formation. Bright clusters ignite, shining like sparks scattered across the merging structures. This cosmic encounter is not destructive in the way we might imagine. Individual stars almost never collide because the distances between them are immense. Instead, galaxies pass through one another like drifting swarms of fireflies, reshaping themselves through gravitational influence. Their dance may last a billion years before they finally merge into a single, larger galaxy. Our own home galaxy, the Milky Way, is engaged in such a slow dance. Far in the future, billions of years from now, it will merge with a neighboring galaxy called Andromeda. But this event is so distant in time that it carries no urgency. It is simply part of the universe's natural rhythm, a reminder that even vast systems are not fixed forever. Beyond individual pairs, gravity organizes galaxies into clusters. These clusters are enormous gatherings containing hundreds or even thousands of galaxies bound together. Within them, galaxies orbit a shared center of mass, moving in grand, looping paths over immense spans of time. Clusters themselves can connect into even larger structures known as superclusters, forming a vast cosmic network that resembles delicate filaments woven through space. This structure is often called the cosmic web. If you could step far outside the observable universe and look back, you would see galaxies arranged along thin strands, with enormous voids between them. It would resemble a glowing neural network or frost spreading across glass, intricate and interconnected. What is especially calming about gravity's dance is its predictability. Though galaxies may collide and reshape, the laws guiding them remain constant. Gravity does not change its mind. It does not falter. It creates order from motion and harmony from complexity. Within each galaxy, gravity also governs the movement of stars. In spiral galaxies, stars orbit the center in coordinated paths, creating the elegant arms we admire. These arms are not fixed objects, but waves of density moving through the galaxy's disk, compressing gas and triggering star formation as they pass. It is like a gentle ripple traveling across a pond, though on a scale so vast that even light needs tens of thousands of years to cross it. At the very centers of many galaxies lie supermassive black holes, millions or billions of times more massive than our Sun. They anchor their galaxies with deep gravitational wells. Yet even these giants are part of the dance. When galaxies merge, their central black holes slowly spiral toward one another, eventually combining in an event that sends gravitational waves rippling through space-time itself. These gravitational waves are subtle distortions in the fabric of the universe, like faint tremors spreading through an invisible ocean. They travel outward at the speed of light, carrying information about distant cosmic events. Even these waves move calmly through the universe, expanding outward in ever-growing circles. As you imagine this vast choreography, notice how nothing rushes. Everything unfolds with patience. Galaxies spin at steady rates. Clusters orbit in graceful loops. The cosmic web stretches quietly across unimaginable distances. The dance of gravity teaches us something deeply comforting. It reminds us that movement does not require haste. Change does not require chaos. Even collisions between galaxies unfold in slow motion, giving stars time to adjust, gas clouds time to ignite, structures time to settle into new forms. In the quiet darkness between galaxies, gravity continues its work. It shapes the paths of wandering dwarf galaxies. It guides the motion of stars at the outskirts of spirals. It holds clusters together against the expansion of the universe. And yet, the universe is expanding. Galaxies on the largest scales are drifting apart as space itself stretches. Gravity works locally to bind structures, while cosmic expansion gently pulls distant regions away from one another. This balance between attraction and expansion creates a dynamic but harmonious cosmos. Imagine yourself floating at the edge of a massive galaxy cluster. Around you, hundreds of galaxies glow softly, each turning in its own rhythm. Their combined gravity curves the very fabric of space, bending light from even more distant galaxies behind them. This bending of light, known as gravitational lensing, creates beautiful arcs and distortions, a visible signature of gravity's presence. Even light, the fastest traveler in the universe, follows gravity's guidance. As you breathe slowly and allow your thoughts to drift, picture the galaxies moving in slow arcs across billions of years. See the faint bridges of stars forming between interacting systems. Watch new stars ignite where gas is compressed by gravitational tides. Feel the immense calm of structures so vast that human worries seem like brief flickers. As we continue our gentle journey through the universe, let us drift inward, past the spiral arms, past glowing clusters of newborn stars, past drifting clouds of interstellar dust, toward the quiet and mysterious hearts of distant galaxies. These central regions are unlike any other place. They are deeper, brighter, and shaped by forces so powerful that even light must obey them. And yet, in the grand rhythm of the cosmos, they too move with a slow and patient calm. At the center of nearly every large galaxy lies something extraordinary, a supermassive black hole. These objects are not small or simple. They can contain millions or even billions of times the mass of our sun, compressed into a region far smaller than a star cluster. And yet, despite their immense gravitational pull, they do not roam through space devouring everything in sight. Instead, they remain anchored at the core of their galaxies, shaping motion quietly from within. Imagine approaching the center of a distant spiral galaxy. From afar, it appears as a soft glow, a bright bulge surrounded by swirling arms. As we drift closer, the density of stars increases. Light becomes richer, more golden, layered upon itself. Stars orbit rapidly here, tracing tight paths around the unseen mass at the center. Their motion reveals what cannot be directly seen. Black holes themselves are invisible. They do not emit light, but the material falling toward them often does. Gas and dust spiraling inward form a structure called an accretion disk, glowing brightly as friction heats it to extraordinary temperatures. In some galaxies, this disk shines so intensely that it outshines all the stars combined. These active centers are known as quasars, brilliant beacons visible across billions of light years. When quasars were first discovered, astronomers were puzzled. How could a single point of light shine brighter than an entire galaxy? The answer lay in the immense gravitational energy released as matter fell into supermassive black holes. The process was not chaotic but structured, governed by physics that unfolds with elegant precision. Yet not all galactic centers are active. Many, including the heart of our own Milky Way, are relatively quiet. Their central black holes exist in a calmer state, occasionally consuming small amounts of gas or stray stars but mostly resting in gravitational stillness. This quiet phase can last for millions of years, giving galaxies time to settle and evolve. There is something deeply peaceful in imagining these cosmic giants resting at the centers of galaxies. They are powerful, yes, but their influence is subtle and balanced. They do not tear galaxies apart. In fact, their gravitational presence may help stabilize galactic structure, guiding stars in their orbits like a conductor guiding musicians in a slow symphony. As we float closer still, we notice how tightly packed the central regions become. Stars here are far more numerous than in the outer arms. If you stood on a planet near the galactic center, the night sky would glow constantly, filled with thousands of bright stars visible at once. Darkness would be rare. The universe would feel full and luminous. And yet, even in this brightness, space remains vast. The distances between stars are still enormous. Collisions are rare. The universe prefers motion over impact, balance over chaos. In some galaxies, jets of high-energy particles stream outward from the central black hole, extending thousands of light-years into space. These jets are created when magnetic fields near the black hole's disk accelerate charged particles to nearly the speed of light. They shine in radio waves and X-rays, forming long, narrow beams that pierce the surrounding darkness. Though energetic, they too evolve slowly, stretching across cosmic time. The centers of galaxies also hold ancient stars, some of the oldest in the universe. These stars formed early in galactic history and have orbited the core for billions of years. They carry within them the chemical fingerprints of an earlier cosmos, preserving memories of a time when heavy elements were rarer and galaxies were younger. If we listen closely, not with ears, but with imagination, we might sense the rhythm of stars circling the core. Each orbit takes thousands or millions of years. Each path is guided by gravity's quiet command. The motion is steady, repeating, like a cosmic heartbeat echoing across ages. One of the most fascinating truths about these galactic hearts is how deeply they connect to the evolution of the entire galaxy. When central black holes are active, they can influence star formation by heating or expelling surrounding gas. In doing so, they regulate how many new stars are born. This balance shapes the galaxy's brightness, structure, and future. And yet, despite their complexity, these processes are not hurried. Everything unfolds in gradual transitions. A galaxy may glow brightly as a quasar for millions of years before dimming into calmness. Star formation may surge, then slow. Matter may spiral inward, then stabilize. There is a profound serenity in this cycle. As you breathe gently, imagine hovering just outside the luminous bulge of a distant galaxy. Stars whirl beneath you in slow arcs. The central region glows like a lantern in deep space. Beyond it stretch the graceful spiral arms, dust lanes weaving like shadows across light. At the very center lies the unseen black hole, not as a monster, but as a gravitational anchor. It does not chase. It waits. It shapes motion simply by being present. Even time behaves differently near these hearts. According to the laws of relativity, clocks closer to massive objects tick slightly slower compared to those farther away. Near a supermassive black hole, time itself stretches subtly. It is a reminder that gravity influences not only motion but the very flow of existence. And yet, despite these strange effects, the overall feeling remains calm. Galaxies endure. Their centers shine steadily. Their stars continue orbiting. Far across the universe tonight, countless galactic hearts glow quietly. Some blaze with quasar brilliance. Others rest in soft radiance. All are part of the same cosmic story, a story unfolding without rush, without urgency, across billions of years. The quiet hearts of galaxies remind us that immense power can exist alongside stillness, that complexity can coexist with calm, that even in the deepest gravitational wells, there is balance. As we continue our journey, we will move outward once again, exploring the luminous arms, the drifting dust, and the regions where new stars are gently born in glowing clouds. Now, as we drift gently away from the quiet heart of a distant galaxy, we move outward into its wide and graceful arms, where light flows like slow rivers across the dark. These spiral arms are not solid structures, but luminous regions shaped by motion and time. They are places of creation, vast nurseries where new stars are born in glowing clouds that shimmer softly against the cosmic night. Imagine floating along one of these spiral arms. From afar, it appears like a bright curve wrapping around the galaxy's center. Up close, it becomes a landscape of gas, dust, and starlight layered in delicate textures. Massive clouds of hydrogen drift here, some stretching across hundreds of light years. Within these clouds, gravity continues its patient work, gently pulling material inward until new stars ignite. These stellar nurseries glow in shades of pink and red because of ionized hydrogen gas energized by nearby young stars. The light is not harsh. It is diffused and dreamlike, spreading outward in soft halos. If you could hover inside one of these regions, you would see dense pockets forming within the cloud, small knots where gravity tightens its embrace. Slowly, almost imperceptibly, those knots heat up. Pressure builds. And then, quietly, a new star begins to shine. The birth of a star is not a sudden flash. It is a gradual awakening. Gas gathers, collapses, and forms a protostar surrounded by a swirling disk of material. Within that disk, particles collide and stick together, forming the earliest building blocks of planets. Over time, the central star ignites nuclear fusion, and light spills outward into the surrounding nebula. Around some newborn stars, jets of material stream outward along magnetic lines, carving delicate shapes into the surrounding gas. These jets glow faintly, tracing lines through the darkness. Everything moves slowly, as though the galaxy itself is breathing. In distant galaxies, star formation can be far more intense than in our own. Some galaxies experience what astronomers call starburst phases, periods when stars are forming at astonishing rates. These bursts may be triggered by gravitational interactions with nearby galaxies, compressing gas clouds and igniting waves of creation across entire spiral arms. And yet, even these bursts unfold across millions of years. From our perspective, they are steady and serene. Within these luminous arms, you would also find clusters of young stars bound together by gravity. These star clusters sparkle like cosmic jewels. Their stars are often hot and blue, burning brightly in their youth. Over time, the cluster slowly disperses as gravitational interactions send stars drifting away into the broader galaxy. Between these glowing regions lie dark lanes of dust. These dust clouds are made of tiny particles, grains of carbon, silicates, and ice. They obscure light from stars behind them, creating intricate patterns across the galaxy's face. If you look at a distant spiral galaxy through a powerful telescope, you may notice these dust lanes weaving like soft shadows through its arms. Though dark in visible light, these regions are not empty. In infrared wavelengths, they glow softly, revealing hidden stars forming within. The universe has many ways of shining, and much of its beauty exists beyond what human eyes can naturally see. As we continue drifting, imagine the gentle rotation of the spiral arm beneath you. Stars orbit the galaxy's center in long, sweeping paths, taking hundreds of millions of years to complete a single revolution. The spiral arm itself is like a wave of density moving through the disk. As gas enters the arm, it compresses, triggering star formation. As it exits, the glow gradually fades. This wave-like behavior means that spiral arms are not permanent collections of the same stars. Instead, they are patterns, regions where stars are born more frequently. The stars themselves move in and out of the arms over time, like travelers passing through a luminous current. There is something profoundly comforting about this constant cycle. Gas becomes stars. Stars shine for millions or billions of years. Eventually, some return material to space through stellar winds or gentle expansions. That material then drifts back into clouds, beginning the process again. Even in distant galaxies billions of light-years away, this cycle repeats. The laws of physics do not change with distance. Hydrogen behaves the same way. Gravity gathers material with the same quiet persistence. Light emerges from fusion in the same steady glow. If you could rest on a planet orbiting a star within one of these spiral arms, your night sky would be extraordinary. Dense clusters of stars would shimmer overhead. Nebulae would stretch across the horizon in faint colors. The galaxy's central bulge would glow softly in the distance. Yet, despite this richness, the feeling would still be peaceful. Space between stars remains vast. Silence remains complete. Motion remains slow. Some regions of distant galaxies contain enormous molecular clouds, reservoirs of cold gas waiting for the right conditions to collapse into stars. These clouds are so large that if one replaced the space around our sun, it would extend far beyond the nearest stars. And yet, within that enormous volume, the average density is still lower than the best vacuum created on Earth. The universe is vast and delicate at the same time. As you relax deeper into this journey, imagine watching a new star emerge from within a glowing nebula. See its light gently pushing back the surrounding darkness. Feel the calm patience of the process. No hurry, no urgency, just the steady unfolding of cosmic creation. Far across the universe, in galaxies whose light is only now reaching us, countless stars are being born at this very moment. Their light will travel for millions or billions of years before touching another world. Perhaps it will never be seen. Or perhaps, someday, another civilization will look up and wonder about the faint glow of a distant galaxy, just as we do tonight. The spiral arms of galaxies are rivers of light flowing through time. They carry the raw material of stars. They cradle newborn suns. They shimmer with dust and gas shaped by gravity's touch. And as we drift gently beyond these glowing regions, we carry with us the quiet understanding that creation in the universe is not loud or sudden. It is soft. It is patient. It is continuous. In the next part of our journey, we will travel even farther outward, beyond the bright disk of galaxies, into the faint halos and mysterious dark matter that hold everything together. As we slowly drift beyond the bright spiral arms and glowing star nurseries, the visible light of the galaxy begins to fade behind us. The dense clusters of stars become fewer. The pink glow of nebulae softens into darkness. Yet even here, far from the shining disk, the galaxy does not end. It continues outward into something vast, mysterious, and almost completely invisible. Surrounding every large galaxy is an enormous halo, a sphere extending far beyond the stars we can see. This halo is not made primarily of glowing gas or bright stars. Instead, it is dominated by something that does not shine at all. It neither reflects light nor absorbs it in any ordinary way. It is called dark matter. Dark matter is one of the most soothing mysteries in the universe. It does not announce itself with brilliance or noise. It reveals its presence only through gravity. When astronomers carefully measure how fast stars orbit within distant galaxies, they discover something curious. The outer stars move much faster than expected, as though an unseen mass is holding them in place. If only visible matter were present, galaxies would spin so quickly that their outer stars would drift away into space. Yet they remain bound, guided by the gravitational influence of something hidden. That hidden presence is dark matter. Imagine floating far outside a distant spiral galaxy. The luminous disk now appears as a glowing whirlpool at the center of an immense, invisible sphere. That sphere, stretching perhaps 10 times wider than the visible galaxy, is composed mostly of dark matter. Though unseen, it outweighs all the stars and gas combined. There is something deeply calming about this idea. The galaxy's structure is supported by something quiet and unseen, like roots beneath a tree. Just as a tree's stability depends on roots hidden below the soil, a galaxy's stability depends on dark matter hidden in the cosmic dark. We do not yet know exactly what dark matter is made of. It does not interact with light the way ordinary matter does. It passes through space without emitting radiation. Scientists have proposed many possibilities, new kinds of particles that rarely interact with normal atoms. For decades, experiments have attempted to detect these particles directly, but they remain elusive. And yet, their presence is undeniable in the grand design of the universe. On the largest scales, dark matter shapes the cosmic web itself. It forms the scaffolding upon which galaxies assemble. In the early universe, regions with slightly higher concentrations of dark matter pulled in normal matter through gravity, guiding the formation of the first stars and galaxies. Without dark matter, galaxies might never have formed at all. If you could see dark matter directly, the universe would look entirely different. Instead of isolated galaxies shining in blackness, you would see an intricate network of filaments, long strands connecting clusters like glowing bridges. At the intersections of these filaments, galaxies gather in groups and clusters, anchored by dense knots of dark matter. The idea that most of the universe's mass is invisible may seem unsettling at first. But in the quiet of this journey, it feels strangely comforting. It reminds us that not everything important needs to be seen. Some forces work silently, supporting structure from behind the scenes. Around distant galaxies, faint halos of ancient stars also drift within the dark matter envelope. These stars are often remnants of smaller galaxies that were absorbed long ago. As dwarf galaxies approach larger ones, gravity stretches them into long streams of stars that wrap gently around the host galaxy. Over time, these streams blend into a diffuse halo, preserving a memory of past mergers. Imagine watching one of these stellar streams from afar. It appears like a soft arc of light, barely visible against the darkness. It curves gracefully around the galaxy, tracing the path of a long-ago interaction. Even here, in the outskirts, gravity continues its patient choreography. The outer halo is a quiet place. Stars are sparse. Distances are immense. If you stood on a planet orbiting a star in this region, the central galaxy would appear as a brilliant swirl dominating half the sky. Beyond it, the universe would stretch endlessly, dotted with faint glimmers of other distant galaxies. And surrounding everything, unseen but present, would be the vast halo of dark matter, shaping motion, holding structure together. In galaxy clusters, dark matter becomes even more influential. Entire clusters are bound by enormous halos that extend far beyond their visible components. When clusters collide, astronomers observe something remarkable. The visible gas slows down and interacts, while dark matter passes through almost unaffected. This behavior provides strong evidence that dark matter is a distinct form of matter, not simply a misunderstanding of gravity. Yet even these collisions unfold slowly, across billions of years. Nothing rushes. The universe prefers gradual transformation. As we drift farther outward still, we notice that the boundary between one galaxy's halo and the intergalactic medium becomes subtle. There is no sharp edge. The galaxy fades gently into the broader cosmos. Gas becomes thinner. Stars become rare. But gravity's influence continues to extend outward, blending with that of neighboring galaxies. This blending creates a sense of continuity. No galaxy exists entirely alone. Each is part of a larger structure, connected through gravity and dark matter to others across millions of light years. There is something profoundly reassuring in this interconnectedness. Even across unimaginable distances, galaxies are not isolated islands. They are nodes in a vast network, shaped by invisible threads. As you breathe slowly, imagine yourself resting within this immense halo. No bright lights surround you now, only faint starlight and the distant glow of the galaxy behind you. The darkness is deep but not empty. It is filled with unseen presence. Dark matter reminds us that much of reality operates quietly. It does not demand attention. It does not sparkle. Yet without it, galaxies would not hold together. Structures would not form. The cosmic web would unravel. Tonight, as you settle into stillness, consider the invisible supports in your own life, the quiet forces that hold things together without being seen. Just as dark matter anchors galaxies, unseen foundations often sustain what shines brightly on the surface. Far beyond the spiral arms, beyond the glowing nebulae and bright clusters, the halo stretches outward into night. It does not glow. It does not flicker. It simply exists, steady and patient. In our next journey, we will travel even farther, beyond individual galaxies and halos, into the immense voids between clusters, where space becomes even quieter and the expansion of the universe reveals itself most clearly. As we continue drifting outward, leaving behind the quiet halo of a single distant galaxy, something extraordinary begins to reveal itself. What once seemed like isolated islands of light scattered randomly across darkness slowly arrange themselves into a grander design. From far enough away, the universe is not chaotic. It is patterned. It is woven. Imagine rising higher and higher above the scene, as though you are ascending beyond ordinary perspective. Individual galaxies become tiny sparks. Galaxy clusters appear as small clusters of dew on an invisible thread. And then, as your view expands further, you begin to see it, an immense network stretching across the cosmos. Long, delicate filaments connect clusters in sweeping arcs, forming a structure so vast that even imagination must soften to hold it. This is the cosmic web. It is the largest known structure in existence. Galaxies are not scattered randomly. They gather along these filaments of matter, like beads strung across invisible strands. Between the filaments lie enormous voids, regions so empty that they contain very few galaxies at all. These voids can span hundreds of millions of light-years, vast quiet chambers within the architecture of space. The cosmic web formed gradually, guided by gravity acting upon both ordinary matter and dark matter. In the early universe, tiny fluctuations in density provided the blueprint. Where matter was slightly denser, gravity pulled more material inward. Over billions of years, these regions grew into the filaments we see today, while less dense areas expanded into vast empty voids. If you could see dark matter directly, the web would appear even more intricate, a glowing scaffold supporting the luminous galaxies that trace its shape. The visible galaxies are merely the highlights, like frost clinging to the edges of a window pane. The underlying structure is much larger and deeper than what light alone reveals. Picture yourself drifting along one of these filaments. Around you, galaxies glow softly, separated by millions of light-years yet connected through gravity. Each galaxy spins quietly, unaware of the immense pattern it participates in. Together, they form a design that spans the observable universe. There is something deeply soothing in this order. Despite the universe's immense scale, despite the billions of galaxies moving independently, a larger harmony emerges. It is not imposed from above. It arises naturally from simple laws repeated over time. Between the filaments lie the cosmic voids. These are not entirely empty, but compared to the dense filaments, they feel vast and silent. If you floated within a void, you might see only a handful of distant galaxies scattered across a wide horizon. The darkness would feel deeper. The quiet would feel more complete. And yet, even voids are part of the pattern. Their emptiness gives shape to the web, just as negative space gives form to art. Without voids, the filaments would not stand out. Without emptiness, structure would not be visible. The cosmic web reminds us that connection does not require closeness. Galaxies may be separated by unimaginable distances, yet they remain linked by gravity's influence. A slight movement in one region subtly affects the balance elsewhere. Everything participates in the same expanding fabric of space-time. As the universe expands, the web itself stretches gently. Filaments lengthen. Clusters drift slightly farther apart. The motion is slow, steady, and continuous, like dough rising in a warm oven. Nothing tears apart violently. Instead, space itself expands, carrying galaxies with it. Within clusters along the web, galaxies interact more frequently. These dense intersections are like cities within the cosmic landscape. Hundreds or thousands of galaxies orbit one another in slow arcs. Gas between them glows faintly in X-rays, heated by gravitational energy. The cluster's combined mass bends light from even more distant galaxies behind it, creating arcs and rings, subtle signatures of space curved by gravity. Farther along the filament, the density thins. Galaxies become fewer. The structure narrows, then widens again at the next cluster. The pattern repeats across billions of light-years, forming a network so immense that it challenges comprehension. And yet, at its heart, the cosmic web formed from tiny beginnings. The fluctuations in density that seeded it were incredibly small, differences of less than 1 part in 100,000 in the early universe. From such delicate variations, gravity sculpted the grandest structure of all. There is comfort in that idea. Great patterns can arise from small beginnings. Complexity can grow from simplicity. Order can emerge naturally from quiet laws. As you breathe slowly, imagine yourself floating at the center of this web. Look in one direction and see a luminous filament stretching into the distance, dotted with galaxies like lanterns. Turn gently and see another filament crossing it, forming a glowing intersection. Beyond that lies a vast void, serene and almost empty. From this vantage point, the universe feels less like scattered chaos and more like a living tapestry. Even light itself traces the web. Photons traveling from distant galaxies must weave through this structure, sometimes bending slightly as they pass massive clusters. Their journeys, lasting billions of years, carry with them information about the web's shape and distribution. Astronomers map the cosmic web by observing millions of galaxies, charting their positions across the sky. The resulting maps resemble intricate lacework spread across space. Every dot represents a galaxy, every cluster and filament reveals gravity's artistry. And still, the web continues to evolve. Gravity draws matter inward along filaments, feeding clusters at their intersections. Galaxies continue merging within these dense regions. The universe is dynamic, yet its motion unfolds so slowly that it feels eternal. If you allow your thoughts to soften, you may begin to sense the deep stillness underlying all this structure. Despite the vast distances and countless galaxies, the cosmos operates on rhythms far slower than human life. The web stretches across billions of years, unchanged by the passing of centuries. Tonight, as you rest in this story, remember that you too are part of this web. The atoms in your body were forged in stars within a galaxy that itself sits along one of these filaments. You are not separate from the cosmic structure. You are woven into it. Far away, across unimaginable distances, galaxies glow quietly along the strands of the great cosmic web. They do not know of one another's existence in any conscious sense, yet they remain connected through gravity and shared origin. In our next journey, we will explore what lies at the very edge of visibility, galaxies so distant that their light is stretched and reddened by cosmic expansion, whispering to us from the earliest epochs of time. Now we journey toward the edge of what can be seen, not the edge of the universe itself, because the universe may not have an edge in the way we imagine, but the edge of visibility, the farthest light that has had enough time to reach us. As we drift farther outward along the great cosmic web, the galaxies grow fainter, smaller, and redder, their glow softened by unimaginable distance. Light, though incredibly fast, is not instantaneous. It travels at a fixed speed, about 300,000 kilometers per second. Even at that speed, crossing the vastness between galaxies takes millions or billions of years. When we observe extremely distant galaxies, we are seeing ancient light that began its journey when the universe was very young. Imagine a photon of light leaving a distant galaxy more than 12 billion years ago. At that time, Earth did not yet exist. Our sun had not formed. The Milky Way itself was still assembling. That tiny particle of light began traveling across expanding space, moving steadily forward without pause. It crossed filaments of the cosmic web, drifted through voids, passed near clusters whose gravity bent its path slightly. For billions of years, it traveled in silence. And only now, tonight, does it arrive. There is something deeply peaceful about this. Light is patient. It does not tire. It does not rush. It simply continues forward until it is absorbed or observed. When astronomers capture that faint glow with powerful telescopes, they are not just seeing a distant object. They are receiving a message from deep time. As the universe expands, space itself stretches. This stretching affects traveling light. Its wavelength becomes longer, shifting toward the red end of the spectrum. This phenomenon is called redshift. The farther away a galaxy is, the more its light has been stretched, and the redder it appears. If we imagine standing at the boundary of visibility, we would see galaxies glowing faintly in deep crimson hues, their light thinned and elongated by cosmic expansion. Some are so distant that they can only be detected in infrared wavelengths, invisible to human eyes but revealed by sensitive instruments. These distant galaxies often look small and irregular. In the early universe, galaxies had not yet settled into the elegant spiral shapes we recognize today. They were compact, chaotic, forming stars at astonishing rates. Some were undergoing rapid mergers, growing quickly in size and mass. When astronomers observe these galaxies, they are peering into cosmic history. They see the universe not as it is now, but as it was during its early chapters. The farther we look, the younger the universe appears. It is like reading an ancient diary written in light. Some galaxies observed today formed only a few 100 million years after the universe began expanding. Their light has traveled for over 13 billion years to reach us. They appear incredibly faint, requiring long exposures from space telescopes to detect. Yet within those faint smudges lies immense activity, stars igniting, black holes growing, structures assembling. Picture yourself floating near one of these early galaxies. Its stars are bright and blue, burning hot and fast. Gas clouds swirl chaotically. The galaxy is smaller than modern giants, but vibrant with creation. Around it, space is darker than it is today because fewer generations of stars have illuminated the cosmos. And beyond it lies even deeper darkness, a time before galaxies existed at all. As we approach the farthest visible galaxies, we near the epoch known as cosmic dawn, the era when the first stars and galaxies began shining. Before that, the universe was filled with neutral hydrogen gas, opaque to certain wavelengths of light. When the first stars ignited, their radiation gradually transformed this gas, making the universe transparent. This transformation is called reionization. It unfolded slowly over hundreds of millions of years. As more stars and galaxies formed, their combined light cleared the cosmic fog. The universe became more transparent, allowing light to travel freely across vast distances. The galaxies we see near this boundary of time played a crucial role in that process. Their collective glow helped shape the universe's evolution. There is something quietly beautiful in knowing that light from these distant galaxies has survived such an immense journey. It has crossed expanding space, endured gravitational distortions, and remained intact long enough to reach our instruments. When we observe it, we are participating in a connection that spans billions of years. The edge of visibility is not a wall. It is simply the limit set by time and light's finite speed. Beyond it, there are undoubtedly more galaxies, perhaps countless more. But their light has not yet reached us. They remain hidden not because they do not exist, but because their photons are still traveling. Imagine billions of unseen photons currently en route, crossing the darkness, destined to arrive millions or billions of years from now. The universe is filled with messages still in transit. As you relax deeper, imagine yourself gently floating among these faint, distant galaxies. Their light is soft, almost fragile, stretched thin by expansion. They do not blaze like nearby stars, they whisper. The farther we look, the more we realize how vast time truly is. Our entire human history occupies only the briefest moment compared to the journey of these photons. Civilizations rise and fall while light continues its steady travel. There is comfort in this scale. It reminds us that the universe moves on rhythms far slower than our daily concerns. The distant galaxies do not hurry. Their light does not rush. Everything unfolds according to steady laws. In the farthest reaches of observation, astronomers sometimes find galaxies that appear surprisingly mature, containing heavy elements and structured forms earlier than expected. These discoveries gently challenge our understanding, reminding us that the universe still holds mysteries waiting to unfold. And that is part of the beauty. The edge of visibility is not an ending, but an invitation. It invites curiosity. It invites patience. It invites wonder. As we conclude this part of our journey, imagine watching a faint red galaxy glowing at the brink of time. Its light began traveling when the universe was in its infancy. It has crossed billions of light years to meet you here. And though it feels distant beyond comprehension, it is connected to you through light, through shared existence within the same expanding cosmos. In our next chapter, we will explore how galaxies communicate across space through radiation beyond visible light, in radio waves, X-rays, and other hidden forms of energy that reveal secrets invisible to the human eye. As we drift even deeper into the cosmic night, we begin to realize something beautiful. Not everything in the universe speaks through visible light. The cosmos is not silent, even though it appears silent to human senses. Instead, it hums, whispers, and pulses through waves of energy that our eyes cannot see but our instruments can feel. These invisible voices travel across space, carrying secrets from distant galaxies. Light that human eyes can see is only a tiny slice of the universe's communication. Beyond that small window lies a vast spectrum of radiation. Radio waves stretch like slow, long ocean waves across the darkness. X-rays move with intense energy, revealing violent and energetic cosmic events. Infrared radiation carries the warmth of star-forming regions hidden behind dust clouds. Each type of radiation tells a different story about distant galaxies. Imagine floating far from any planet, far from any star, inside pure cosmic darkness. Suddenly, you begin to sense faint signals passing through you. Not sound, not touch, but patterns of energy. Radio signals from spinning neutron stars flicker steadily like cosmic lighthouses. X-ray emissions burst from active galactic centers where matter falls towards supermassive black holes. Infrared light glows softly from hidden stellar nurseries buried inside dense nebulae. These invisible signals help astronomers understand galaxies that cannot be fully studied through visible light alone. Dust and gas often block optical light, especially in young or distant galaxies. But other wavelengths pass through, revealing hidden structures beneath. Radio astronomy has allowed scientists to map enormous structures across the universe. Some galaxies emit powerful radio jets from their centers. These jets can stretch for thousands of light years, flowing outward like cosmic rivers of charged particles moving near the speed of light. Though powerful, these jets still move slowly across cosmic timescales, evolving over millions of years. Picture these jets as long glowing streams of invisible energy. They move outward from the galactic core, carving paths through surrounding space. They do not move violently. Instead, they expand steadily, shaping surrounding gas and influencing future star formation. Infrared astronomy reveals another gentle side of galaxies. Many star-forming regions are hidden behind thick clouds of dust that absorb visible light. But infrared radiation can pass through these clouds, allowing scientists to observe newborn stars before they fully emerge into brightness. It is like listening to a baby's heartbeat before seeing the child's face. There is something deeply calming about this hidden universe. It suggests that beauty exists even when we cannot directly see it. The cosmos is not limited to what human senses can perceive. It is richer, deeper, and more layered than our natural vision allows. X-ray radiation tells stories of the most energetic cosmic events. When matter falls into black holes, it accelerates rapidly and heats to extreme temperatures. This produces high-energy radiation that can travel across galaxies. X-ray telescopes orbiting Earth capture these signals, allowing scientists to study violent but distant phenomena safely from our quiet planet. Yet even these violent events unfold slowly when viewed across cosmic time. A black hole may consume matter over millions of years. A jet may extend gradually across space. The universe does not hurry even in its most powerful processes. As you relax deeper into this story, imagine yourself becoming sensitive to all these invisible cosmic voices. You are floating in darkness, surrounded by signals traveling from distant galaxies. Some signals left their sources billions of years ago. They are just now passing by you, continuing their journey outward forever. The universe is constantly broadcasting its history. Every galaxy is sending information about its structure, temperature, composition, and motion through radiation. Astronomers are like listeners, collecting these faint whispers and turning them into knowledge. Even the cosmic microwave background radiation is a whisper from the earliest universe, a faint echo of the time when the cosmos first became transparent to light. This radiation fills all space, extremely uniform and calm, like a cosmic lullaby that has been playing since the beginning of time. If you could hear the universe in sound instead of light, it might resemble a slow, deep hum, a continuous vibration stretching across existence. Not loud, not chaotic, just steady and eternal. The invisible voices of the universe also remind us that reality is much larger than what we directly experience. Humans evolved to see only a small band of light because that was useful for survival. But the universe does not limit itself to human perception. It continues radiating across all wavelengths, constantly communicating with itself. Distant galaxies especially rely on these invisible messages to reveal their secrets. Some are too far or too faint to study with optical telescopes alone. But by combining multiple wavelengths, astronomers can reconstruct a complete picture of cosmic structures. Imagine these different wavelengths as layers of a dream. Visible light shows the surface beauty of galaxies. Infrared reveals hidden birthplaces of stars. Radio waves show large-scale structure. X-rays reveal powerful energetic cores. Together, they create a full cosmic story. As we float quietly through this invisible symphony, notice how peaceful it feels. There is no rush. Signals move at constant speeds. Radiation spreads outward like ripples on a calm cosmic ocean. Far away, in distant galaxies, events are still happening. Stars are being born, black holes are feeding, clusters are interacting. But all of these events send their stories outward slowly, patiently, across the universe. And somewhere in the darkness, these signals will continue traveling long after their sources have changed or disappeared. The universe is not just a place of matter and gravity. It is also a place of information. Energy carries memory. Light carries history. Radiation carries knowledge across time and space. As you prepare to drift deeper into our journey, let this thought settle gently in your mind. Even in darkness, the universe is always speaking. You only need to listen in the right way. In the next part of our journey, we will travel closer to the mysteries of time itself, exploring how distant galaxies help us understand the past, present, and future of the universe in one continuous story. As we drift deeper into the cosmic ocean, we begin to understand one of the most magical truths of the universe, that looking into space is also looking into time. The farther we look, the further back in history we travel. Distant galaxies are not just objects in space. They are windows into the past, showing us how the universe looked billions of years ago. Imagine holding a candle in a dark room. The light from the candle does not reach your eyes instantly. It takes a tiny moment to travel through space. Now imagine stretching that idea to cosmic scales. The light from distant galaxies has been traveling for so long that when it finally reaches Earth, it is no longer showing us the galaxy as it is now. Instead, it shows us the galaxy as it was when the light first began its journey. In this way, telescopes are not just tools for seeing distance, they are machines for seeing history. If you could travel far enough away from Earth and look back through a powerful telescope, you would see our planet in its past forms. You might see ancient continents, early oceans, or even dinosaurs roaming the surface. Travel even farther, and you would see Earth before life existed. Travel farther still, and you would see the formation of the planet itself inside a young solar system cloud. The universe is like a massive library where each galaxy is a book written in light. When astronomers observe extremely distant galaxies, they are studying the early chapters of cosmic history. These galaxies often appear smaller, brighter, and more chaotic than modern galaxies. Star formation was more active in the early universe because there was more available gas and dust floating freely through space. Over billions of years, galaxies matured. Star formation slowed. Structures became more stable. The universe began to cool and settle into its current rhythm. There is something deeply calming about this cosmic aging process. The universe did not start in perfect order. It grew into order slowly, patiently, like a garden blooming across billions of years. Time itself behaves differently on cosmic scales. According to the laws of relativity, time is influenced by gravity and speed. Near massive objects like black holes or neutron stars, time moves slightly slower compared to regions with weaker gravity. This means that in different parts of the universe, time can pass at slightly different rates. Though these differences are extremely small in everyday life, they become significant in extreme environments. Near supermassive black holes, time dilation can become noticeable. To an outside observer, events near the black hole may appear to slow down. Light leaving those regions becomes stretched and redshifted, carrying the signature of gravitational influence. But even these strange effects unfold slowly. The universe does not rush through time. It bends time gently, like soft fabric being stretched carefully rather than violently torn. Distant galaxies help scientists understand how the universe evolves across time. By studying galaxies at different distances, Astronomers can build a timeline of cosmic evolution. Nearby galaxies show the universe's recent past. Farther galaxies show earlier cosmic ages. The most distant galaxies reveal the universe's infancy. It is like watching a movie by looking at individual frames scattered across space. When you gaze at the night sky, you are not seeing one moment in time. You are seeing thousands of different moments layered together. Each star you see may be from a different era of cosmic history. Some stars may have died long ago, but their light is still reaching us. Others are still shining, sending out messages that will travel long after Earth changes. There is something deeply poetic in this idea. Light is like memory. It preserves the existence of distant objects even after those objects have changed or disappeared. In the far future, astronomers may see different skies than we do today. As the universe continues expanding, distant galaxies will move farther apart. Some galaxies that are visible today may eventually move beyond the observable universe. Their light will never reach future civilizations. This does not mean they will disappear. They will simply become unreachable, like distant islands drifting beyond the horizon of time and space. The universe is always changing, yet always preserving its history through light. Every photon is a traveler carrying information across ages. Some photons carry the memory of stars that no longer exist. Others carry the memory of galaxies that have merged into new cosmic forms. As you relax deeper into this story, imagine floating through layers of time. You pass by nearby stars glowing in the present. Then you move further, seeing Earth's past reflected in faint starlight. Then you move even farther, watching the early universe awaken from darkness. Everything is connected through time as much as through space. And somewhere, far beyond the reach of human telescopes, there are still galaxies whose light has not yet reached us. Their stories are still traveling. Their histories are still unfolding in silence. In the next part of our journey, we will explore how galaxies age, how they change from vibrant star-forming systems into quieter, more peaceful cosmic structures over billions of years. As we continue our quiet journey through the universe, we begin to witness something that feels almost human. Galaxies, like living things, grow older. They are not alive in the biological sense, yet they go through life cycles. They are born from clouds of gas. They shine brightly in youth, and eventually they grow calmer, quieter, and more stable as time passes. In the early universe, galaxies were energetic and chaotic. Star formation happened rapidly because there was still a large amount of free hydrogen gas floating through space. Young galaxies shone brightly with massive blue stars that burned hot and fast. These stars lived short lives compared to calmer, older stars like our Sun. When they died, they exploded in supernovae, scattering heavy elements back into space and enriching future generations of stars. But as billions of years passed, galaxies began to change. The supply of cold gas slowly decreased as it was either consumed by star formation or heated by energetic events near galactic centers. Without fresh gas, star formation began to slow down. Galaxies entered quieter, more stable phases of existence. Imagine a young galaxy as a bright, lively city filled with lights, energy, and movement. Now imagine an older galaxy as a peaceful coastal town at night. Still beautiful, still glowing softly, but much calmer. Older galaxies often contain more red and yellow stars rather than bright blue ones. This is because blue stars burn out quickly, leaving behind longer-lived, cooler stars that shine gently for billions of years. The light from these older stars feels softer, more relaxed, almost sleepy in appearance when viewed from great distances. Elliptical galaxies are especially associated with older cosmic ages. These galaxies often formed through repeated mergers of younger galaxies. When galaxies collide, their spiral structures can be destroyed, leaving behind smooth, rounded shapes filled mostly with older stars. Star formation in these galaxies is usually very low because they contain little cold gas. And yet, even in their quietness, these galaxies remain majestic. Their stars orbit in slow, random patterns rather than in organized spirals. The motion feels less like a whirlpool and more like floating particles drifting peacefully in a warm breeze. The aging of galaxies is not a sad process. It is simply transformation. The universe does not value youth over age. Instead, it values balance and continuity. Young galaxies bring creation and energy. Older galaxies bring stability and calmness. In some regions of the universe, galaxies have already aged significantly. These regions are often located in dense clusters where galaxies interact frequently. Frequent interactions can accelerate aging because gravitational disturbances may remove gas needed for new star formation. Imagine watching a galaxy slowly grow quieter over billions of years. At first, it glows brightly with star formation. Then the brightness slowly softens. Star birth slows to a gentle pace. Eventually, only long-lived stars remain, shining steadily like candles that burn for ages. There is something deeply peaceful about this cosmic aging process. Nothing is wasted. The material that formed stars in the past is recycled back into space. Stellar winds and supernova explosions spread elements across galaxies, ensuring that future stars and planets can still form elsewhere. This cosmic recycling is one of the universe's most beautiful patterns. Nothing truly disappears. Everything is transformed. Even black holes participate in the aging process of galaxies. Over time, black holes may grow larger by consuming surrounding matter, but they also influence their galaxies by regulating star formation. Their gravity can heat nearby gas, preventing it from collapsing into new stars too quickly. In this way, they act like cosmic regulators, maintaining balance within the galaxy. As we drift farther from these aging galaxies, we begin to see how age is relative across the universe. Some galaxies are still young, actively forming stars. Others are middle-aged, maintaining steady star production. Others are ancient, glowing softly with the light of billions of years of history. The universe itself is aging too. Since the Big Bang, it has been expanding and cooling. In its earliest moments, the universe was extremely hot and dense. Today, it is much colder and more spread out. Yet this aging is not decay. It is evolution. If you imagine the universe as a living ocean, then galaxies are like islands that change shape slowly over time. Some islands grow through mergers. Some shrink in activity. Some remain steady and peaceful for billions of years. As you relax deeper into this journey, imagine watching a distant galaxy age before your eyes. Not quickly, but slowly, like watching seasons change and fast forward but across cosmic scales. Stars are born like spring flowers. Young galaxies are bright like summer sunlight. Mature galaxies feel like autumn warmth. Ancient galaxies feel like quiet winter nights. The universe does not fear age. It embraces it. In the far future, many galaxies will have aged significantly. Star formation will become rare as available gas continues to decrease. The universe will become darker and quieter, though not empty. Old stars will still shine. Black holes will still exist. Light will still travel slowly through expanding space. The story of galaxies is not a story of beginnings and endings. It is a story of continuous transformation across time. As we prepare to move forward in our journey, we will explore how galaxies sometimes experience dramatic transformations, sudden events that reshape them even after billions of years of calm existence. As we drift deeper into the long story of the universe, we begin to see that even the most peaceful galaxies are not always still. The cosmos is patient, yes, but it is also dynamic. Across billions of years, galaxies occasionally experience dramatic transformations. These changes are not sudden explosions of chaos. Instead, they are slow cosmic encounters that reshape entire worlds of stars with gentle persistence. Imagine two distant galaxies floating in the darkness, each moving along its own gravitational path. For millions or even billions of years, they may travel toward one another without noticing. The distance between them is so vast that their motion feels almost frozen when viewed from human time scales. But if time were sped up, you would see them slowly approaching, their outer halos beginning to feel each other's gravitational pull. These encounters are called galactic mergers. A merger does not happen quickly. It is more like two clouds drifting together in slow motion. At first, only the outer edges of the galaxies interact. Stars rarely collide because space between stars is so incredibly large. Instead, gravity stretches the galaxies into long, glowing shapes. Spiral arms may become elongated. Dust lanes may twist and shift. New waves of star formation may ignite where gas clouds compress under gravitational pressure. There is something strangely beautiful about these interactions. They are not destructive in the dramatic sense we often imagine. Instead, they are transformations, cosmic rebirths on enormous time scales. When galaxies begin merging, their central black holes also begin moving toward one another. Over time, these massive objects form a binary system, orbiting each other in slow spirals. Eventually, after millions or even billions of years, they merge into a single, even more massive black hole. This final union releases gravitational waves, ripples in the fabric of space-time that travel outward through the universe like echoes of cosmic motion. Even these waves move gently. They do not shake galaxies apart. Instead, they quietly pass through matter, carrying information about distant events. During mergers, star formation can sometimes increase dramatically. When gas clouds collide and compress, they can trigger starburst regions where stars form rapidly. These regions glow brightly, filled with hot, young stars that shine blue and brilliant against the darker background of older stellar populations. Yet even this burst of creation does not last forever. Eventually, gas supplies are consumed or heated, and star formation slows again. The galaxy settles into a new form, carrying the memory of its encounter within its structure. Some galaxies experience multiple mergers across their lifetimes. Over billions of years, these repeated interactions can completely reshape a galaxy's appearance. Spiral galaxies may become elliptical galaxies after losing their organized rotating structure. The stars within them continue orbiting, but in more random paths rather than orderly spiral motion. And still, through all these changes, the universe maintains its calm rhythm. If you could watch a merger unfold across cosmic time, it would feel like watching slow-moving tides reshape a shoreline. Nothing happens abruptly. Everything moves with quiet inevitability. There is also a poetic symmetry in these encounters. When galaxies merge, they are not simply destroyed or absorbed. Instead, their stars, gas, and dust combine to create something new. Old structures give birth to new ones. Past histories are preserved within the resulting galaxy's stellar composition and motion patterns. Even our own galaxy has experienced many mergers throughout its history. Small dwarf galaxies have been slowly absorbed into its halo, leaving behind faint streams of stars that still orbit as ghostly reminders of past cosmic encounters. These stellar streams are like faint memories written across the night sky. They curve softly around galaxies, barely visible but scientifically important. They help astronomers reconstruct the history of galactic evolution. As you relax deeper into this cosmic story, imagine floating near one of these merging galaxies. You would see enormous structures of stars stretching across space. Bright knots of star formation would glow softly. Dust clouds would drift like shadows across light. The motion would feel slow and majestic, like watching mountains slowly drift together over millions of years. Despite the scale of these events, the universe remains peaceful. There is no panic in cosmic transformation. The universe does not fear change. It simply allows change to unfold. Mergers also play an important role in the growth of supermassive black holes. As galaxies merge, their central regions funnel gas and dust inward. This material feeds black holes, allowing them to grow larger over time. Some of the most massive black holes in the universe likely grew through repeated mergers and long periods of quiet feeding. Yet even these powerful objects do not dominate the universe through chaos. Their influence is subtle, expressed through gravity and energy regulation rather than violent destruction. The universe seems to prefer balance. Creation and destruction occur together, like breathing in and breathing out. Young galaxies bring energy and creation. Old galaxies bring stability and memory. Mergers bring transformation. Together, they create the long cosmic story that continues unfolding tonight. in darkness far beyond human sight. As we continue our journey, we will move even further into the future of galaxies, exploring how cosmic expansion will shape their destiny over trillions of years. As we drift even farther into cosmic time, we begin to look not only into the past of galaxies, but also into their future. The universe is not just a story of birth and growth, it is also a story of expansion and separation. For billions of years, space itself has been stretching slowly, gently pulling galaxies away from one another like dots painted on a balloon that is slowly being inflated. This expansion was first discovered when astronomers noticed that distant galaxies were moving away from us. The farther a galaxy is, the faster it appears to move away. This does not mean galaxies are actively flying through space. Instead, space itself is expanding between them. Galaxies are mostly carried along with this expansion, like leaves floating on the surface of a slowly flowing river. In the far future, this expansion will dramatically change how the universe looks. Galaxies that are currently visible in the night sky will slowly drift beyond the observable universe. Future civilizations may look up at the sky and see only their own galaxy, surrounded by darkness. Imagine standing on a planet billions of years in the future. The sky would be very different from today. The Milky Way would dominate the sky as a glowing island of stars. Other galaxies would have drifted so far away that their light would no longer reach that future world. The universe would feel quieter, more isolated, though still beautiful in its own way. The expansion of the universe is driven partly by what scientists call dark energy. Dark energy is even more mysterious than dark matter. While dark matter pulls structures together through gravity, dark energy pushes space apart, accelerating the expansion of the universe. It acts like a gentle but persistent pressure stretching the cosmos. Dark energy does not act violently. It works slowly, across billions of years, but its effects become more noticeable over cosmic time. The expansion of the universe is actually speeding up, not slowing down. This discovery surprised scientists when it was first observed. In the distant future, galaxies within local groups may remain bound together by gravity. For example, galaxies that are close neighbors may eventually merge into larger, single galaxies. But galaxies far beyond these local groups will drift away forever, unreachable even by light. If you could watch this process from outside the universe, you would see galaxies slowly becoming more isolated. Clusters would merge into larger structures. Then even those structures would become isolated islands of matter floating in an ever-expanding darkness. There is something strangely peaceful about this future. The universe is not rushing toward destruction. It is slowly spreading out, becoming cooler and quieter. Stars will continue to shine for trillions of years, especially long-lived red dwarf stars, which burn fuel very slowly and can shine far longer than massive blue stars. Eventually, star formation will decline significantly. The available gas needed to create new stars will be mostly used up or scattered. The universe will enter what scientists sometimes call the degenerate era, where most bright objects have already lived out their natural lifetimes. But even then, the universe will not be empty. White dwarf stars will slowly cool and fade. Neutron stars will remain extremely dense and stable. Black holes will continue to exist, slowly consuming surrounding matter. Over incredibly long time scales, even black holes may evaporate through a process called Hawking radiation, releasing tiny amounts of energy back into space. This process would take unimaginable amounts of time, far longer than the current age of the universe. As you imagine this distant future, feel the slow rhythm of cosmic time. Nothing happens quickly. Even the end of bright cosmic activity is gradual and calm. There is beauty in this slow fading. The universe does not end in sudden darkness. It transitions gently toward colder and quieter states. Yet even in that distant future, light will still exist. Some photons will continue traveling through space for eternity, never being absorbed, never reaching a destination. They will drift endlessly across expanding space, carrying memories of galaxies that once shone brightly. The future universe will be large, cold, and quiet, but still structured by gravity and energy conservation. Some regions will remain bound together. Others will drift apart forever. As we think about this vast future, it reminds us that time itself is one of the universe's most powerful forces. Galaxies are not just shaped by gravity and matter, but also by the slow passage of time. The story of galaxies is therefore a story of patience. Earth takes billions of years. Growth takes billions of years. Aging takes billions of years. Transformation takes billions of years. Even the future unfolds slowly. As we prepare to move further in our journey, we will explore one of the most mysterious ideas in cosmology, the possibility of other universes beyond our own cosmic horizon. As we drift even deeper into the endless quiet of space and time, we begin to approach one of the most mysterious boundaries in cosmology, the cosmic horizon. This is not a physical wall. There is no solid barrier floating in space. Instead, it is a limit defined by time, light, and the expansion of the universe itself. It represents the farthest regions of the universe from which light can ever reach us. Imagine standing on a quiet shoreline, watching waves roll in. Some waves reach the shore. Others are already too far away to ever arrive. The cosmic horizon is like that shoreline of visibility. Beyond it, galaxies still exist, but their light will never reach us because space between us is expanding too quickly. Light from beyond the horizon is not lost in the traditional sense. It simply cannot overcome the stretching of space. Even though light moves at its maximum possible speed, the universe's expansion can carry distant regions away faster than light can travel through space. This does not violate physics because it is not objects moving through space faster than light. It is space itself expanding. As we float near this horizon, the distant galaxies become extremely faint. Their light is stretched into longer wavelengths, becoming almost invisible to normal instruments. These galaxies feel like memories of places that can no longer be visited. There is something peaceful about this boundary. It reminds us that knowledge has limits, and even the universe contains regions of gentle mystery. The cosmic horizon does not suddenly cut off reality. Instead, it slowly fades objects from view, like watching lights dim gradually at the end of a long night. In the far future, the cosmic horizon will become even more restrictive. As dark energy continues accelerating expansion, more and more galaxies will drift beyond observational reach. Future civilizations may live in a universe where only their local galaxy cluster is visible. They might not know that other galaxies ever existed. Astronomers sometimes call this future state the island universe scenario. Each galaxy cluster becomes like a separate island floating in an enormous ocean of darkness. Communication between these islands would become impossible, not because of technology limits, but because of cosmic expansion itself. Yet even this idea is not frightening. It is simply another phase in the universe's long evolution. The universe does not rush toward isolation. It drifts toward it slowly over trillions of years. The cosmic horizon also teaches us about perspective. What we can see depends not only on distance but also on time. Light from distant galaxies may have already passed us, traveling outward forever, carrying information about our existence. In a strange way, we are also sending signals into the future. Radio waves from Earth are slowly traveling through space. One day, far in the future, those faint signals may reach regions that are currently beyond our horizon today, though that may take billions of years. As you relax deeper into this cosmic story, imagine standing at the edge of visibility. Behind you are the bright galaxies of the nearby universe. In front of you is deep darkness, slowly expanding, gently pushing everything apart. But this darkness is not empty. It is filled with potential galaxies, potential stars, potential histories still unfolding beyond our reach. Scientists continue studying the cosmic horizon to understand the ultimate fate of the universe. Some theories suggest expansion will continue forever. Others suggest different possibilities depending on the nature of dark energy. But regardless of the final outcome, the process will unfold slowly, peacefully, across unimaginable time scales. Even if the universe becomes extremely quiet in the far future, it will still contain structure. Black holes may dominate cosmic matter. Degenerate remnants of stars may drift through space. Gravity will continue shaping motion, even in the absence of new star formation. There is beauty in this quiet future. It suggests that the universe does not require constant creation to remain meaningful. Even slow fading can be beautiful. As we approach the next part of our journey, we will explore one of the deepest mysteries of all: what might lie outside our universe, beyond the cosmic horizon itself. As we drift beyond the limits of what we can see, our journey enters one of the most mysterious and poetic ideas in modern cosmology: the possibility that our universe may not be alone. While we cannot directly observe other universes, some scientific theories suggest that our cosmos might be just one bubble floating within a much larger multiverse. Imagine floating in an endless cosmic ocean. Instead of galaxies, there may be countless universe bubbles, each expanding in its own way, each with its own physical laws, constants, and cosmic history. Some universes might be filled with stars and galaxies like ours. Others might have different kinds of matter, different forces of nature, or completely different structures of reality. This idea comes from theoretical physics and cosmological models that try to explain the earliest moments of the universe. During the very first fractions of a second after the cosmic beginning, space may have expanded extremely rapidly in a process called inflation. Some versions of inflation theory suggest that inflation may not have stopped everywhere at once. Instead, different regions of space could have stopped inflating at different times, creating separate universes that drift apart forever. If this is true, then each universe would be like a bubble forming inside an infinite cosmic foam. These universes would likely never interact with one another. Even light would not be able to travel between them because space between universes would continue expanding. They would remain isolated, like distant islands separated by oceans that cannot be crossed. There is something strangely comforting about this idea. It suggests that our universe is part of something even larger and more mysterious than we can currently understand. The cosmos may be far more vast than even our largest telescopes can reveal. Different universes might have different fundamental constants. In some universes, gravity might be stronger or weaker. In others, atoms might not form in the same way. Some universes might never form stars or galaxies at all. Others might evolve in completely unexpected ways. Our universe seems finely balanced for complexity and life. If physical constants were slightly different, stars might burn too quickly or not form at all. Planets might not exist. Chemistry might be impossible. This delicate balance is sometimes called the anthropic principle. The idea that we observe this universe because it allows observers to exist. But in a multiverse, all possibilities might exist somewhere. As you imagine floating among these universe bubbles, feel the quiet beauty of diversity on a cosmic scale. Some universes may be bright and energetic. Others may be dark and cold. Some may live briefly before collapsing. Others may expand forever. And yet, even in this grand multiverse idea, the same calm patience remains. If multiple universes exist, they too would evolve slowly across time. Stars would still burn. Gravity would still shape structures. Time would still flow gently forward. Scientists cannot yet prove the existence of other universes, but they continue exploring mathematical models and cosmic observations for clues. The idea remains one of science's most fascinating mysteries. Even if other universes exist, they do not diminish the beauty of our own. Instead, they make our universe feel like a rare and precious arrangement of cosmic circumstances. As you rest deeper into this story, imagine our universe as a glowing bubble drifting silently through endless cosmic darkness. Inside this bubble, galaxies shine. Stars are born. Time moves forward. Life emerges and wonders about existence. Outside the bubble, there may be more bubbles. Or there may be something completely different, a reality beyond our ability to imagine. But the universe we know continues expanding gently, shaping itself through gravity, dark matter, and dark energy. Whether alone or part of a larger multiverse, it continues its slow cosmic story. In the next part of our journey, we will move from grand cosmological ideas back towards something more personal and intimate, exploring how distant galaxies ultimately connect to life, consciousness, and the cosmic origins of everything we know. As we continue our peaceful journey through the deepest ideas of the cosmos, we return closer to something very personal, life itself. After traveling across galaxies, time, dark matter, and even the possibility of other universes, we discover a beautiful truth. Life is not separate from the cosmos. Life is made from it. Every atom inside living beings was once forged inside stars or during cosmic events billions of years ago. Hydrogen, the simplest and most common element, was created during the earliest moments of the universe. Heavier elements like carbon, oxygen, nitrogen, and iron were formed inside the cores of stars through nuclear fusion. Even heavier elements were created during supernova explosions, where dying stars scattered these elements across space like seeds carried by cosmic winds. Imagine a distant galaxy billions of years ago. Inside one of its spiral arms, a massive star reaches the end of its life. The star collapses under its own gravity and explodes in a brilliant supernova. For a brief moment, that explosion can outshine an entire galaxy. But the explosion is not destruction alone. It is creation. Supernovae spread heavy elements across interstellar space. Over time, those elements drift into new gas clouds. Gravity pulls them together. New stars form. Around those stars, planets may form from leftover dust and rock. This cycle of birth, death, and rebirth is one of the most beautiful patterns in the universe. Our own solar system formed from such recycled stardust about 4.6 billion years ago. The Sun formed from a collapsing cloud of gas and dust enriched by previous generations of stars. The Earth formed from rocky material left over after the Sun ignited. The oceans formed from water molecules that likely came from comets and icy bodies that delivered water to the young planet. In this way, life on Earth is directly connected to ancient galaxies and long-dead stars. The carbon in your body may have once been inside the core of a star. The oxygen you breathe may have been created in stellar fusion reactions. The iron in your blood was likely formed during supernova explosions. You are, in a very real sense, made of cosmic history. There is something deeply comforting about this idea. It means that humans are not outsiders in the universe. We are products of it. We are not observers standing apart from cosmic processes. We are participants. Life itself may be a natural outcome of cosmic chemistry given enough time and stable environments. On planets with liquid water, organic molecules can gradually form more complex structures. Over millions of years, chemistry can become biology. Distant galaxies may contain planets with similar processes happening. Perhaps somewhere in the universe, other forms of life are looking up at their night sky, wondering about their own cosmic origins. The universe does not rush the creation of life. It allows enormous amounts of time for complexity to develop. Stars live and die. Planets cool and stabilize. Molecules combine. Eventually, under the right conditions, life emerges. This long, slow process mirrors the peaceful rhythm of the cosmos itself. As you imagine floating through space, think about how connected everything is. The light from distant galaxies, the atoms inside your body, the planets orbiting stars, all are part of the same universal story. Life is not separate from galaxies. Life is one of the ways the universe becomes aware of itself. Even the process of evolution mirrors cosmic evolution. Simple structures gradually become more complex. Over time, systems organize into greater levels of structure and awareness. Tonight, as you rest within this cosmic story, imagine yourself floating among stardust clouds drifting through distant galaxies. These clouds are not empty. They contain the ingredients for future stars, future planets, and perhaps future life. The universe is still creating. Even now, somewhere in distant galaxies, new stars are being born. New planets are forming. New possibilities are emerging. In the next part of our journey, we will move toward the ultimate future. What might happen to galaxies, stars, and life when time stretches far beyond human imagination? As we move further into the distant future of the cosmos, we arrive at a time that scientists sometimes call the long cosmic night. This is not a sudden ending. There is no dramatic darkness that falls all at once. Instead, the universe slowly becomes quieter, colder, and more still over unimaginable spans of time. Stars are the first to begin fading in this era. Massive stars have already lived their short, brilliant lives. Only the slow-burning stars remain, small red stars that consume their fuel very slowly, shining faintly but steadily for trillions of years. These stars are like gentle lanterns left burning long after a festival has ended. But even these stars will eventually fade. As available hydrogen gas continues to be used up, new star formation becomes extremely rare. Galaxies that once glowed brightly with star birth will become quiet collections of aging stars slowly orbiting massive black holes. The universe will no longer be filled with bright, energetic light the way it once was during its younger days. Yet even in this quiet future, motion will continue. Stars will still orbit. Planets may still circle dead or dying stars. Black holes will still exist as massive gravitational anchors holding remnants of cosmic history together. In this far future, black holes will become some of the most dominant objects in the universe. They will slowly grow by consuming nearby matter and merging with other black holes during rare cosmic encounters. Over extremely long time scales, black holes themselves will begin to shrink due to a strange quantum process called Hawking radiation. Hawking radiation is extremely weak. So weak that it is almost impossible to detect with current technology. But over trillions upon trillions of years, even black holes will slowly evaporate, releasing tiny amounts of energy back into the universe. The largest black holes will be the last objects to disappear. As black holes fade, the universe will become darker than ever before. This future era is sometimes called the black hole era or the dark era of the universe. Most bright objects will have disappeared. What remains will be faint stellar remnants drifting through enormous cosmic distances. White dwarf stars will cool and slowly turn into cold, dark stellar cores. Neutron stars will remain incredibly dense and stable for extremely long periods of time. But even these objects will slowly lose energy over trillions of years. If you could witness this era, the sky would look very different from today. There would be almost no bright stars visible. The Milky Way and other galaxies would have long since merged into a single massive galaxy or drifted apart beyond reach. The night sky would feel quieter, deeper, and more isolated. But even then, the universe would not be truly empty. Energy itself cannot be destroyed. It only changes form. Even in the coldest future universe, tiny amounts of radiation would still drift through space. Photons that were created billions of years ago might still be traveling endlessly, never being absorbed, never reaching their destination. There is something deeply poetic about this idea. Light can outlive its sources. As you imagine this long cosmic night, feel the stillness of space stretching endlessly. No rushing, no sudden events, just slow fading and gentle transformation. The universe does not end in violence. It ends in quietness. Yet even in this quiet future, gravity will remain. Gravity is one of the most persistent forces in existence. Even when matter becomes extremely sparse, gravity will continue shaping the motion of whatever remains. Some theories suggest that the universe may continue expanding forever, eventually reaching a state where temperature differences disappear. This state is sometimes called heat death, not a dramatic destruction, but a gradual approach toward complete equilibrium, where energy is evenly distributed. Even this concept is not frightening in a cosmic sense. It is simply another phase of universal evolution. The universe began in extreme heat and density. It may end in extreme cold and expansion. Birth and death are simply transformations across time. As you rest within this vision of the distant future, imagine floating alone in an immense, dark cosmos. There are no bright galaxies nearby. Only faint, dim remnants of ancient cosmic history. But even here, existence continues. Time continues flowing. In our final journey section, we will step beyond even this far future and explore philosophical questions about meaning, existence, and why the universe may have chosen to create complexity and consciousness at all. As we drift even deeper beyond physical events and into philosophical space, we begin to ask a question that has followed humanity since the first time someone looked up at the night sky. Why does the universe exist in such a way that complexity, beauty, and life can emerge? There is no single scientific answer to this question, but there are many fascinating perspectives. The universe does not appear rushed or chaotic in its long-term evolution. Instead, it seems to allow complexity to slowly emerge from simplicity, like patterns forming in slow-moving water. In the earliest moments of the universe, everything was extremely simple. There were only basic particles and energy fields. No stars, no galaxies, no planets, no life. Yet over billions of years, gravity, chemistry, and time worked together to create layers of structure. First came atoms, then clouds of gas, then stars, then galaxies, then planets, then chemistry, then biology, then consciousness capable of observing the universe itself. It is almost like the universe is learning to observe itself through living beings. Some scientists and philosophers suggest that consciousness may be a natural outcome of increasing complexity. Just as galaxies formed from small density variations in the early universe, life may have formed from small chemical variations in early planetary environments. The universe does not seem to favor sudden creation of complexity. Instead, it favors gradual emergence. There is beauty in this slow unfolding. It suggests that existence is not random noise but structured possibility. The laws of physics allow matter to organize itself into stable patterns over long periods of time. Even distant galaxies participate in this cosmic story. Their stars produce heavy elements that eventually become part of planets where life might evolve. Their gravitational structures help distribute matter across cosmic scales. Their light carries information about cosmic history. In this sense, galaxies are not just physical objects. They are also part of the universe's long process of self-organization. Imagine floating through deep space and looking at distant galaxies. They are not just collections of stars. They are time machines, chemistry factories, and potential birthplaces of future life. Some theories in cosmology even suggest that universes might naturally tend toward states where complexity can emerge. Not necessarily life, but structure, patterns that can store information and evolve over time. Information itself may be one of the most important concepts in understanding existence. The universe does not only contain matter and energy, it also contains information about how that matter and energy are arranged. Light traveling from distant galaxies carries information about their history. Radiation from stars carries information about their composition. Even gravitational waves carry information about cosmic events. In this way, the universe is constantly recording its own story. As you relax deeper into this cosmic reflection, imagine existence as a vast, slow symphony. Galaxies are like musical notes. Stars are like melodies. Gravity is like rhythm guiding everything in harmony. There is no conductor forcing events to happen. The music emerges naturally from the laws of physics themselves. Human curiosity is also part of this cosmic pattern. The desire to understand the universe is a natural extension of the universe becoming aware of itself through conscious minds. Even the act of studying distant galaxies is part of cosmic evolution. Telescopes are like eyes the universe has built to observe itself across time and space. In distant galaxies, there may be other civilizations asking the same questions. They may look up at their skies and wonder about existence, just as we do. This possibility creates a beautiful sense of connection across the universe. Even if civilizations are separated by vast distances, they may share the same curiosity, the same sense of wonder. The universe does not provide answers easily. Instead, it encourages exploration and discovery. As we approach the final sections of this story, we move from science into deeper reflection, thinking about what it means to be part of a universe that is so vast, so old, and so patient. As we approach the final chapters of our cosmic journey, we find ourselves returning to something deeply human: curiosity. Curiosity is one of the quiet forces that has driven exploration, science, and understanding throughout history. It is the same curiosity that once led humans to build telescopes and look deeper into the night sky, trying to understand distant galaxies and the secrets they hold. The universe itself seems to encourage curiosity. Every time scientists discover something new about galaxies, they uncover even deeper mysteries. For example, discovering dark matter led to the realization that most of the universe's mass is invisible. Discovering dark energy revealed that the universe's expansion is accelerating. Each answer seems to create more questions. Distant galaxies are especially powerful sources of curiosity because they allow us to see different periods of cosmic history. When we observe galaxies at various distances, we are essentially looking at different chapters of the universe's story. Nearby galaxies show recent cosmic evolution. Farther galaxies show early universe behavior. The most distant galaxies show the first moments of cosmic structure formation. Curiosity is not just a human trait. It may be a universal property of complex systems. Systems that can gather information about their environment tend to become more stable and adaptive over time. Stars gather matter through gravity. Galaxies gather stars through structure formation. Living organisms gather information through perception and learning. In this sense, curiosity is like gravity for knowledge. Imagine drifting through deep space and watching civilizations across distant galaxies develop their own forms of science. Perhaps they too built telescopes to study their skies. Perhaps they too wondered about their origins. Perhaps they too asked whether they were alone. Even if we never meet other civilizations, the act of searching for them is meaningful. It expands our understanding of the universe and our place within it. The search for extraterrestrial life is often guided by studying exoplanets around distant stars. Scientists look for planets in habitable zones where liquid water could exist. Water is considered a key ingredient for life because of its chemical stability and ability to support complex molecular reactions. Some distant galaxies may contain billions of planets capable of supporting life under the right conditions. The universe is so vast that even extremely rare events may happen many times across cosmic scales. There is something peaceful about this idea. It suggests that life may not be a cosmic accident, but rather a natural expression of the universe's complexity. Curiosity also connects generations across time. The light from distant galaxies we observe today was emitted billions of years ago. When we study that light, we are learning about the past. Future civilizations will study our present through the light we are currently sending into space. Our radio signals, television broadcasts, and artificial transmissions are slowly traveling outward through the cosmos. Though weak, they carry information about humanity's existence during this brief moment in cosmic history. Curiosity is therefore also a form of communication with the future. As you relax deeper into this story, imagine curiosity as a soft light traveling across space. It does not move quickly or forcefully. It simply continues moving forward, searching for understanding. The universe itself may be shaped by curiosity in a symbolic sense. The laws of physics allow complexity to form. Matter organizes itself into stars, planets, and life. Conscious beings then arise and begin studying the universe that created them. It is like the universe asking questions about itself through living minds. Even distant galaxies participate in this story of curiosity. Their light travels across billions of years to reach observers. Without observers, their beauty would still exist, but it would not be appreciated or studied. With observers, the universe gains a way to reflect on itself. As we move toward the final section of our journey, we prepare to return to the quiet feeling of cosmic peace, bringing together everything we have learned about galaxies, time, life, and existence. And now, as our journey gently comes to its quiet end, we return to the feeling that has accompanied us from the beginning: peace. Not the absence of movement, but the harmony of slow cosmic motion. The universe is not a place of constant chaos. It is a place where immense forces move patiently across unimaginable distances, shaping beauty through time. After traveling through distant galaxies, cosmic webs, dark matter halos, black holes, and the far future of the universe, we arrive at a simple but powerful realization. Everything in the universe is connected through time, space, and energy. Stars, planets, life, and consciousness are all part of the same cosmic story. Imagine floating in deep space, far beyond any galaxy, far beyond any cluster of stars. There is no sound, no rush, only gentle darkness filled with faint, distant light. Those faint lights are galaxies, glowing softly across billions of light years. They do not shine loudly. They shine calmly. The universe does not demand speed. Even light, the fastest thing known to exist, takes time to travel. Gravity works slowly but steadily. Evolution works patiently. Cosmic expansion unfolds gently over billions of years. The universe is not in a hurry. There is beauty in this slowness. If you look back across everything we have explored, you can see a cosmic cycle. The universe began in intense heat and density. Galaxies formed. Stars were born. Planets formed. Life emerged. Conscious beings began asking questions. Civilizations developed science and technology. Then those civilizations began looking outward, trying to understand their place in the cosmos. The universe is like a great breathing system. It expands, creates structure, allows complexity to emerge, and continues evolving. Some parts of the universe shine brightly with star formation. Others grow quiet and dark. But neither state is permanent. Even in the distant future, when stars fade and black holes evaporate, existence will continue in some form. Energy will still exist. Photons will still travel. Gravity will still influence motion. The universe will remain even if it becomes quieter. There is something deeply comforting about this cosmic perspective. Human life, though brief compared to cosmic time, is meaningful because it is part of something far larger. Every thought, every discovery, every dream is connected to cosmic history stretching back billions of years. You are made of stardust. You are made of elements created inside ancient stars that once shone in distant galaxies. Those stars lived, died, and scattered their material across space so that planets, oceans, and life could form. You are not separate from the universe. You are one of the ways the universe experiences itself. As our journey ends, imagine slowly drifting back toward Earth. The Milky Way appears as a soft glowing river of light across the sky. The sun is a bright but ordinary star among billions. The planet below is quiet, alive, and beautiful. The universe will continue long after this story ends. Galaxies will continue rotating. Stars will continue shining. Time will continue flowing like a slow, endless river. And somewhere, far across the universe, distant galaxies will continue sending their ancient light into the darkness, patient, calm, and eternal. Now rest. Feel the cosmic peace surrounding everything that exists. The universe is vast, but it is also gentle.